Okay, welcome back. Here we're going to look at a practical example using complex numbers, and this is what you're going to be doing in the lab. So, if you remember from mathematics, we have a complex number such that it is in the form a plus bi, where I satisfies I squared equals -1. So with complex numbers, if we think back to our maths, we know that A is the real part and B is the imaginary part. Okay, so here we've got two complex numbers, one called Z1, one called Z2. For Z2, C is the real part and D is the imaginary part. We can perform multiplication on our two complex numbers such that when we get the result, we get AC minus BD plus BC plus ADI. Now, you can see these are bracketed here, and the reason we've bracketed these is because this is in the form of A plus BI. So this here is going to be our real part, and this is going to be our imaginary part. Now, if we have a look at this problem, what we want to do this multiplication is get 4 bits of information in, 2, 3, 4, which is going to be A, B, C, and D. And we want to get 2 bits of information out, which is going to be the real result and the imaginary result. Okay, so this is what we want, and if we have a look up at our function prototype at the top, we can see this in another form. So we've got in one real, in one imaginary, in two real, in two imaginary, out 3 real, out 3 imaginary. So in one real is going to be A, our in one imaginary is going to be B, our in two real is going to be C, our in two imaginary is going to be D, our out 3 real is our real result, and our out 3 imaginary is our imaginary result. Okay, so we can see how these relate. So we've then got main, okay, and we've named these Z1, Z2, and Z3. So all we're saying here is Z3 becomes the result of Z1 times Z2. So we can draw a box and pointer diagram here. I'm going to run out of a bit of room, but that's okay. And we can draw these out. So we've got 6 things here. I'll draw all of those out. I'll go ahead and fill those in. Okay, so now we've got our box and pointer diagrams. We've got Z1 real, Z1 imaginary, Z2 real, Z2 imaginary, Z3 real, and Z3 imaginary. So we're at this stage. We then get the user to enter the real part of Z1, the imaginary part of Z1, the real part of Z1, and the imaginary part of Z2, sorry. So I'm just going to make up some values. I'm going to go 1, 2, 3, 2. Okay, so that's done. So we're now down here. And I'm just going to get rid of this. And we're going to need to draw another box and pointer diagram, because we're going to pass some values here. So Z1 real is going to just be 1. Z1 imaginary is going to be 2, Z2 real is 3, and Z2 imaginary is 2. Here we're sending the address of the real part and the imaginary part of our result. Now the reason for that is that's because that's where we want the answer to be in. So when you want to pass something back, you need to pass a reference. So let me quickly put together this box and pointer diagram of all the parameters here. Okay, so now we've got our complex number function's box and pointer diagram in its own scope, and we're going to start passing these values in. So the Z1 real evaluated to 1, so we pass 1 into in1 real, so we get a 1 here. In1 imaginary, we pass a 2. In 2 real, we pass a 3. And into imaginary gets evaluated to 2, and we pass it into imaginary. The other two here, we've got the addresses of. So we're passing the address of Z3 real. Now, you'll notice that this has a star. So this is a pointer type. It's a pointer to a float, and we can see that we're pointing to the real part. Okay, we're passing the address in, so this is holding that address. And same with the imaginary part. I'll just go up here. We're passing that address in. So now we get into the function itself, and we are going to evaluate the right-hand side first. So we've got in1 real times in2 real minus in1 imaginary times in2 imaginary. Now, if we remember, we've got A, C, minus in1 imaginary is B, and in2 imaginary is D, and we can see that that matches up to the formula exactly. Okay, so we can calculate this. So we get in1 real, which is 1 times 3 minus in1 imaginary is here, so it's 2 times 2. So here we get 3 minus 4, and then we get minus 1. Now, this whole thing evaluates to minus 1, but where are we going to store it? So we're going to store this minus 1, not in out 3 real, but we're dereferencing it. So where out 3 real points. So we've got 1 star, so we follow this once, and then we go and store the value here. We now do the same thing with the second part. So we've got in1 imaginary, which is 2 times the real part of the second one, which is 3, plus in1 real, which is 1, times into imaginary, which is 2. So we've got 6 plus 2, and we've got 8 here. Once again, the 8 doesn't get stored in out 3 imaginary, it's dereferenced, so we go to where it's pointing and we store that value. Once that function's completed, we've lost all reference to this function, so it's as good as gone. But on returning, we have the values that we need. We've got the output. So now we can just go ahead and print these to the screen. Okay. So this is how it works. Okay. This is how we pass values in and get things by reference. And this is a nice little example of where this would be extremely useful. And we're going to use this in our assignments